Hey, this is Leach with Simpson Math, and I'm here with a quick mini lecture over even and odd functions. So an even function is defined as one that if you were to evaluate the function at negative x, it simplifies to just be the original function, f of x. What this means graphically is that this is a symmetric about the y-axis. So if I was to plug in negative x into x squared, well, negative x times negative x is positive x squared, so it's just that x squared. Similarly with the absolute value of x, if I plug in a negative x, absolute value of negative is x is that positive x, so nothing changes. Compare that to the odd function. If I evaluate the odd function at the same thing, so same thing on the left side, so if I plug in a negative x into function f, it will then simplify to a negative f of x. So what happens to this one graphically is it turns out to be symmetric about the origin. Looks like kind of an 180-degree rotation. If you were to rotate 180 degrees, it's the same thing. Or another way of thinking about this is it's symmetric about the y-axis and the x. So if you do both flip over x and flip over y, it'll then be the same thing. So notice if I plug in a negative x into just x, I'm left with negative x, which is the negative value. If I plug in a negative a negative x into x cubed, negative x and negative x and negative x is a negative x cubed, and that works as well. So that follows along with the other two. You'll notice that square root of x is never odd or even. We just refer to this as, often we'll ask, is it even, odd, or neither? But I do like never odd or even. I like writing it that way because that is a palindrome. Notice this is never odd or even. How about that? So I have a few quick examples of showing this math at play. So this first example, we're asked to show that w of x, which is negative x squared, is an even function. So to do that, we're going to evaluate w at negative x. We're going to plug in negative x, and let's see what we get. So if I plug in a negative x into here, this is that negative from our original function is still hanging out. And then I'm going to replace x with negative x. If I do a negative x times negative x, that's the same thing as negative x squared. We know that a negative x times negative x is a positive x squared. And notice that nothing changes, that this right here is my original w function. So since w of negative x equals w of x, it is an even function. Graphically, if I have this parabola here and I was to switch it around, that, it might not be able to see it on the recording, but I have an arrow pointing there and an arrow pointing there, and it's symmetric around the y-axis. All right, now let's show that k of x, which is 4 times the cube root of x, is an odd function. So to do that, again, we plug in negative x into the function. So let's do that, plug in a negative x. And I can rewrite negative times x as negative 1 times x. And, well, negative 1, this is kind of tricky, but the cube root of negative 1 is negative 1. What can I multiply by itself 3 times to get negative 1? Negative 1 times negative 1 times negative 1 is negative 1. So that's what this math is just showing you, is that the cube root of negative 1 is, in fact, negative 1. So I end up with 4 times negative 1, which is just negative 4 on outside of here. So notice what's happened. I've gone from 4 times the cube root of negative x to negative times 4 the cube root of x. What is negative times 4 the cube root of x? Well, k of x is 4 cube root of x. So all I've done is I've just basically ended up with a negative tacked on the front. So we've gone from being k of negative x to a negative k of x. So this is in fact odd. And again, if you have a cube root function, even one that's been stretched, it is now symmetric about the origin, or that point 0, 0. All right, this next set is a similar idea, similar math, but instead of me saying determine that it's even or determine that it's odd and me giving it to you, it's saying is it even, is it odd, or is it neither? So let's take a look at j of x is x squared plus 1. So is this odd? Is this even? Is this neither? So just a reminder of what to do. So take j of negative x. So evaluate j of negative x. Does it equal j of x? If it does, it's even. Does it equal a negative j of x? If so, it's odd. If it doesn't do either of these, then it's neither. So I want you to take a second, pause the video, and evaluate j of negative x and see if it equals either of those. If it doesn't, it's not either even or odd. All right, let's see how you did. All right, so j of negative x, well, I can plug in a negative x into that squared. A negative x times a negative x is a positive x squared. So x squared plus 1, well, x squared plus 1, that is j of x. So notice I've said that j of negative x does in fact equal j of x, so it is even. Graphically, if I take this function, it's just the parabola shifted up 1 unit. So notice that it is just a reflection around the y-axis. All right, for this last example, let's determine if m of x, which is x plus 1, quantity squared, is an even function, odd function, or neither. So evaluate m of negative x. So what we're going to do is plug in a negative x. If you get m of x, it's even. If you get a negative m of x, it's odd. If you don't get either, it's neither even nor odd. All right, let's see how you did. So m of negative x, if I plug in a negative x, so replace the x with negative x, just drop the parentheses, they're not needed, so negative x plus 1, quantity squared. I can just swap these two around. That's kind of about it I can do. Notice this does not equal the original function, which is x plus 1, so it is not even. And then even if you try to do fancy things with factoring out a negative 1, that would then be a minus 1, and then if you were to bring it out, it doesn't, nope, nothing, things like that don't work. It's not odd either, so it is neither. And I can confirm this to you graphically. So this blue graph right here, this is x plus 1 squared, so notice it is shifted to the left 1. And if I was to reflect this over the y-axis, I would get this light blue graph. And then if I was to reflect it around the origin, I would get this orange graph. And notice that orange graph, that is a reflection over both the x and the y-axis. You have to do them both, or just reflect it over the origin. And notice I don't get the same thing. For it to be even or odd, if I reflect around the y-axis, it would be the same. Or if I reflect around the origin, it would be the same. But both of these graphs are two distinct, different graphs. So m of x, which is x plus 1 squared, is neither even nor odd. So I hope this quick little mini lecture helped you understand even and odd functions, and I will see you in the next video.